All right, so we are on day 3. And there's just a little information up at the top. Some of the stuff we talked about already and some we haven't. We have talked about base 10 when there is no base, no subscript, okay, where there should be on a log, then we take it as a 10. And they actually call these common logs, okay? We have not talked about a base of E yet, but that is coming up. Okay, so we can ignore that one for now. And then we have to talk about the non-base 10. So when your base isn't 10, that we know how to rewrite it so that we can type it into our calculator. Okay, that we have talked about before. We know that the base, okay, goes in the basement or the denominator of your fraction. Okay. All right, so there's ways to solve log equations. Remember, you have to check your answers in original equations. As we just talked about in the warm-up, remember that your base cannot be 0 and it cannot be negative. Okay. So in this one, we could rewrite that. Therefore, we could type it in our calculator and get an answer. If we're solving for x, which is in the base, we know that sometimes log form is not the best form, and we could rewrite it into exponential form, and therefore we can solve. All right, and then we have to remember that the negative cannot be, your base can't be a -6, and so it gets rejected. It can't be in the domain. Okay. If we're solving for this x here, and in log form sometimes isn't helpful, we can go to exponential form where we can go ahead and type that right into our calculator and get an answer. All right, so we're going to go through these and make sure that we know how to do each one. All right, so number 1 says solve each of the following equations for the value of x. Round your answers to the nearest hundredth if necessary. So if they don't come out nice and clean, we'll have to round them. All right, here we go. 4 to the x equals 100. Well, in this one, if you're solving for x and it's an exponent, that's a good indication that you're going to need logs. And so real quick, let's write down our little cheat sheet off to the side here. I'll put it down here in the bottom. But remember that if you're in exponential form, it spells Ben. Okay? When you go to log form, B still comes first, but then the N and E kind of switch positions there, that the N comes in first, second, and then the E comes last. All right, so since we're in exponential form, we're solving for an exponent. That is the main reason why we need logs, because logs will equal our exponent. So we're going to go ahead and write the word log. The base is the subscript, which is 4. Okay? Then the number comes next, which is 100, and then equal to the exponent. And why this helps us is because that we can type this into our calculator as long as we change it into a division problem. Log 100 will go on top, log 4 will go on the bottom, and that, when we type it into our calculator, will give us our value of x. Just make sure you close the parentheses, especially after the 100. All right, and when you type it in, you should end up with x equals 3.32192 ... They asked us to round to the 100th, which is just the second spot, and it's not going to move it, and so we're going to say our answer is x equals 3.32. Okay, cool thing is you could check it. If you go back to the original equation and you type in 4 raised to the 3.32, it's not going to give you exactly 100 unless you use the full unrounded decimal, but it should definitely give you something close to 100. Okay? All right, so remember that when you are solving for an exponent, you need logs. Okay, some people freeze up and forget that little bit of information, and then they get stuck on how to solve that, and they lose a lot of credit on their questions. All right, part B. Again, notice what you're solving for. It's x, which is in the exponent. Therefore, we need logs again. And so we're going to use our little cheat sheet here on the bottom, and we're going to go ahead and put it back into log form. So the first thing we do in log form is write the word log. The base, which is the subscript, is 6. Okay? Then the 50 comes next, and then equal to the exponent of x plus 3. Why this helps us is because we can type this into our calculator as long as we change what it looks like and do log of 50 divided by log of 6. And when we type it in, we end up with 2.1833 ... equal to x plus 3. To solve for x, we're going to have to subtract that 3. And we end up with x equals negative 0.816658, ... They asked us to round to the nearest hundredth, which is the second spot. Look next door, and we're going to say x equals negative 0.82. Okay. All right, next one up. Again, take a look where your x is. It's in the exponent, and therefore we're going to need logs. Okay, so we're going to go ahead and write the word log. Our base, which is what the exponent is on, is 1.03. That becomes our subscript. Then the 2 comes next, and then equal to the exponent of x over 2 minus 5. It's an ugly exponent, but that's okay. Remember, we could type this into our calculator if we change it into a division problem. And once we type in log of 2, make sure you close your parentheses, divided by log of 1.03. We should end up with 23.4497 ... equal to x over 2 minus 5. I'm going to go ahead and add the 5, and I'm going to end up with 28.4497 equal to x over 2. Because the side is divided by 2, I'm going to multiply it by 2, multiply this side by 2, and I'm going to end up with x equals 56.899 ... Okay. Hundredth. That 9's going to round the 9 up. That 9's going to round the 8 up to a 9, and we're going to end up with 56.90. All right. Let's take a look at the bottom ones here. In letter D. Again, your x is your exponents, and therefore we need logs. All right. What's different about this one, though, is that, does everybody see how we have like 4 things? The 4, the 17, the 5, and the x divided by 3. When we go into log form, there's only 3 spots. There's only a spot for the base, which is 5. There's only a spot for the number, which is the 4, and the exponent, which is x over 3. So we have one step to do before we go into log form. Most people will like to multiply the 17 by the 5. However, you can't, because that x divided by 3 is only on the 5. If you put the 17 and the 5 together with multiplication, then the x over 3 is on both of them. You don't want it to be on both of them. You only want it to be on the 5. And so that's why 17 is going to have to disappear with some division here. So it's gone from this side. And then 4 over 17, it's an ugly decimal, so I think I might just leave it as 4 over 17. But I have 4 over 17 equal to 5 raised to the x divided by 3. But now we have our 3 parts, so now we can go into log form. So I'm going to go ahead and write the word log. My base is what the exponent is on, which is the 5, and that becomes my subscript. And then my number is 4/17, and then that's equal to my exponent of x over 3. Remember that this can be typed into your calculator as long as you change it into a division problem. And once we type that into our calculator, make sure that you close the parenthesis after the 4/17. Okay. This side should give us negative 0.89902 ... equal to x over 3. Because you're dividing by 3, we're going to multiply by 3. And that's going to end up with x equals negative 2.6970 ... to the nearest hundredth, which is the second spot. And our answer is going to come out to be x equals negative 2.70. Okay. All right, part E. Again, you're solving for an exponent. However, in this one, kind of like in D, there's too many things to put this into log form. Even though we know we need log form, we can only put it into log form if we have the three things that have positions in the log form, which is the base, which is 10, the number, which right now is 17, and the exponent, which is x. And so we can see that the 4 and the 3 kind of have to get rearranged so that they're not there. So what I'm going to do first in this one is I'm going to add the 3 first. Now I end up with 20 equals 4, 10 to the x. So you notice how I removed one of our numbers, okay? And so we're getting closer, but this just turned into what we did in D. So now we have to realize we have to get rid of the 4, and we have to get rid of it with division. And that's going to come out to be a nice 5 equals 10 to the x. And now we're ready for log form. So we're going to write the word log. The base is what the exponent's on. It becomes our subscript, then the 5, and then equals our exponent. And we can rewrite that as log 5 divided by log 10 equals x. However, we could also just type in log 5 into our calculator since the base is 10. Our calculator, when we tell you use that log button, has a base of 10. Or we can just keep doing what we are used to doing with the other questions. When we type that in, it should come out to be x equals 0.69897 ... to the nearest hundredth. And we end up with x equals 0.70. Oops, I should have done that in red since I did all my other answers in red. Not that it matters. There we go. All right. We had 3 questions left, and they're pretty short questions. Notice these ones are already in log form. Okay. However, solving for where x is in each one of them might be a little bit tricky. Okay. And these are kind of like our warm-ups. So we're going to go ahead and say, well, maybe log form isn't the best. Maybe if we go back to exponential form. So our base is x. Our exponent is the 3, since logs equal their exponents. And then that's going to be equal to 27. So we could do one of two things. We could do the cube root on each side, or we can use our reciprocal power. Reciprocal power of 3 is 1/3. And that way those would equal 1. And x to the first is just x. And 27 to the 1/3 power is 3. And we don't have to worry about a second answer because we have an odd number down here, making it an odd root, which is only one answer. All right, next one up. To solve for x, I think let's try bend form again, or exponential form, whatever you want to call it. Your base is 5. Your exponent is what a log is equal to, so 4, and then equals x. That we can type right into our calculator. 5 to the 4th, right in, and we end up with 625. All right, part H. Let's see. All right, so what we have to realize for this is already x equals. And so we just have to realize that this can be typed into our calculator as long as we change it into a division problem of log of 126 divided by log of 6. And when we type that in, we end up with x equals 2.6991 ... to the nearest hundredth. And we end up with an answer of 2.70. Funny, all of these rounded to just have 0.70 on the bottom. And that one's finished. All right, so hopefully, no matter what you're asked to solve for, where that x is in the equation, if it's an exponential, change it to logs. If you're in logs, sometimes you have to change it to exponential. Okay? And I say sometimes because in H right here, we were in log form and we wanted to keep it there. All right, we got a couple problems on the back, and I'll see you guys there.